One Israeli soldier who went through the hell of the Yom Kippur War spoke a phrase that went around the world and made even seasoned military personnel shudder. He said, "So, if this weapon is firing at you, the good news is that you are dead, because you definitely won't survive the injuries from it." This man was not talking about a missile, not about a bomber, and not even about a tank volley. He was talking about a mortar, the largest mortar on planet Earth, which to this day remains in service with the Russian army. 240 millimeters of pure destruction. A mine weighing 130 kilograms, capable of turning a multi-story building into a pile of rubble in a single shot. Furthermore, this mortar can fire nuclear munitions with a yield of 2 kilotons in TNT equivalent, and this makes it one of the most terrifying weapons ever created by man. Its name is Tyulpan, and today we will tell its story from the very beginning. The 240 millimeter caliber did not appear out of nowhere. It has a long and bloody pedigree that stretches through 2 world wars and has roots in the late 19th century. This caliber came to the world's land armies from the Navy, where large caliber guns were commonplace for battleships and coastal batteries. The French were the first to think of taking heavy barrels off ships and putting them on land carriages to crush enemy fortresses and fortifications. The result was so impressive that other great powers soon followed suit. By the beginning of the First World War, 240 millimeters became one of the key calibers of heavy siege artillery on both sides of the front. The British released their famous 9.2-inch caliber howitzer, which in conversion gave those same 240 millimeters. The Americans created their 240 millimeter howitzer, which was actively used in France. And in the Russian Imperial Army at that time, French-designed mortars were used. The 240 millimeter short model of 1915, which was called Baton, and the 240 millimeter long model of 1916. Russian artillerymen quickly appreciated the destructive power of this caliber and learned to use it with lethal accuracy, which was noted more than once even by opponents. But the 240 millimeter weapons gained truly terrifying fame in the Second World War. The Germans had the heavy siege guns K3 and K4 of 240 millimeter caliber in service, and it was these monstrous barrels that participated in the blockade of Leningrad and the siege of Sevastopol. German artillerymen methodically shelled Soviet fortifications regardless of the consumption of shells or casualties among the civilian population. Every arrival of a 240 millimeter shell left behind a crater the size of a small house and destruction from which it was impossible to hide in any basement. The defenders of Leningrad and Sevastopol knew this caliber firsthand and called it nothing other than a suitcase because of the characteristic sound of a flying shell, which made the blood run cold. The Soviet command perfectly realized what colossal destructive power this caliber possessed. And even before the start of the war in 1938, a promising program for introducing mortars into the Red Army was adopted, starting from rifle companies and ending with artillery units of the reserve of the High Command. The 240 millimeter caliber mortar stood as a separate line in this program as a weapon of special power, capable of solving strategic-level tasks. Perhaps the choice of exactly this caliber was influenced by the combat experience of the Russian Imperial Army, where French 240 millimeter mortars proved to be a formidable and effective weapon. However, creating a mortar of such a monstrous caliber turned out to be a task of incredible complexity. Soviet designers faced technical problems that required absolutely innovative solutions, even in such basic things as aiming at a target and loading. Try to imagine, a mine weighs more than a centner. It needs to be lifted somehow, lowered into the barrel, and at the same time ensure firing accuracy for kilometers ahead. Our engineers struggled over this task for 5 whole years, but the first 2 prototypes created by 1943 turned out to be completely unsuitable for combat use. The war was in full swing. Shells and mines were needed by the front like air, and the 240 millimeter mortar still remained an unattainable dream for Soviet artillerymen. And then a man whose name is forever inscribed in the history of domestic weaponry took up the task. Boris Ivanovich Shavirin, a talented designer and a true genius of mortar business, began work on a completely new project in January 1944. Where others saw a dead end, he saw a path, and it was his solutions that formed the basis of the weapon that decades later would make Russia's enemies pray at the mere sound of its shot. Shavirin approached the task completely differently than his predecessors. Instead of trying to scale already existing mortar schemes, he began designing from a clean slate, relying on his rich experience in creating mortars of smaller calibers. Boris Ivanovich, by that time, was already a legend of the Soviet defense complex. It was he who developed a whole line of mortars that went through the entire Great Patriotic War and earned respect not only from Soviet soldiers, but also from the enemy. Now he faced a much more ambitious task, to create the most powerful mortar in the world, and he was determined to see the matter through to the end. Already in 1944, the first factory tests of the new weapon were conducted, and the results were encouraging. Shavirin's design fundamentally differed from the failed prototypes. He found original engineering solutions for the loading and aiming system, which allowed the crew to handle the heavy mines without superhuman efforts. However, 6 long years of refinement and improvement passed from the first tests to adoption into service. The mortar underwent endless range firing. Its design was refined time and again, eliminating identified shortcomings. And finally, in 1950, the M240 mortar was officially adopted by the Soviet Army. It was a colossal achievement of domestic design thought. For the first time in history, a mortar of such caliber was put into service, capable of throwing 130-kilogram mines to a distance of almost 10 kilometers. Production of the M240 was launched at full capacity, and Soviet artillery units of the reserve of the High Command began to receive the new formidable weapon. The crews underwent intensive training, mastering the difficult procedure of working with a mortar of such caliber. Every shot required coordinated actions of the entire crew, and the loading process looked like a real ritual where any mistake could cost a life. Nevertheless, Soviet mortarmen quickly mastered the new equipment and were ready to use it in battle. But fate decreed otherwise. In 1958, production of the M240 was suddenly stopped, and the reason for that was one man, Nikita Sergeyevich Khrushchev. The first secretary of the Central Committee was literally obsessed with rocket technology and sincerely believed that ballistic missiles and nuclear weapons would completely replace traditional artillery on the battlefield. Not only mortars fell under the hot hand. Khrushchev cut funding for aviation, the surface fleet, and many other weapons programs that he considered outdated. Hundreds of artillery barrels were sent to warehouses. Design bureaus lost orders, and experienced engineers were forced to switch to other projects. A whole direction of the domestic defense industry turned out to be effectively frozen. Almost 10 years passed before the situation changed. After Khrushchev's resignation in 1964, the new leadership of the country gradually began to restore balance in the armed forces. Generals and marshals, who all these years had been gritting their teeth while watching the destruction of artillery, finally got the opportunity to speak out, and their arguments turned out to be irrefutable. No missile could replace artillery support for infantry in close combat, and no nuclear charge was suitable for destroying a single enemy pillbox or bunker. Artillery still remained the god of war, and giving it up was a deadly dangerous misconception. Meanwhile, events were happening across the ocean that finally convinced the Soviet leadership of the need for urgent changes. In Vietnam, the American Army mass-produced self-propelled artillery units, and the results of their combat use made a strong impression on Soviet military specialists. The Americans could quickly move their self-propelled guns through the jungle, strike, and immediately change position, escaping return fire. The Soviet park of self-propelled artillery by that time was critically outdated. The best units like the IS-122 and Su-100 were still products of the Great Patriotic War and did not meet modern requirements in terms of mobility, protection, or rate of fire. The gap between Soviet and American self-propelled systems grew every year, and our Defense Department understood this perfectly. A decision matured quickly. The Soviet Union needed not just a new mortar, but a fundamentally new self-propelled system capable of carrying a 240-millimeter barrel on an armored chassis, firing and moving without outside help. Such a weapon would combine the monstrous destructive power of a heavy mortar with the mobility and protection of modern armored vehicles. And in 1966, work began at the Experimental Design Bureau No. 3 of the Ural Transport Engineering Plant. Georgy Sergeyevich Efimov was appointed the chief designer of the project, a man who was to create a weapon that no army in the world would have an equal to. A year later, in 1967, by a decree of the Central Committee of the Communist Party of the Soviet Union and the Council of Ministers of the Soviet Union, the program of experimental design work was officially approved. The project received a name that would later become legendary: Tyulpan. Efimov and his team faced an engineering puzzle that no one in the world had solved before them. It was necessary to fit a 240-millimeter mortar onto a tracked chassis so that the machine could not only carry this monstrous barrel off-road, but also fire directly from it, withstanding the colossal recoil with every shot. To start with, the designers turned their attention to the chassis that had been developed in 1955 to 56 for the Krug anti-aircraft missile system. The platform looked promising, tracked, quite spacious, with good cross-country capability, but very soon it became obvious that in its original form it was categorically unsuitable for a heavy mortar. The chassis turned out to be insufficiently massive to withstand the recoil of a 240-millimeter barrel, and the designers had to remake it so radically that less than 20% of the units and mechanisms remained from the original model. In fact, Efimov created a new machine, preserving only the general layout idea from the original. Parallel to the Tyulpan, a 152-millimeter self-propelled howitzer Akatsiya was being developed on the same redesigned chassis, which allowed for unifying production and making both machines cheaper. The heart of the new platform was the V-59 diesel engine with 520 horsepower, which accelerated the heavy machine to 62 kilometers per hour on the highway and provided a cruising range of 500 kilometers. For an armored giant weighing over 27 tons, these were excellent indicators, allowing the Tyulpan to perform marches together with motorized rifle and tank units without falling behind the general column. The hull of the machine was assembled from steel armor plates and divided into 3 compartments. In the front part, the engine transmission compartment was located, to the left of which the driver's seat was arranged. Behind the driver's back was the commander's workplace with a rotating turret, from where he could observe the battlefield and correct fire. The fighting compartment occupied the entire rear part of the hull. There, stowage for ammunition and seats for the other crew members, operators, and the gunner were located, who took their places on both sides of the ammunition stowage. In the rear part of the hull, 2 fuel tanks were installed, providing the machine with that very impressive cruising range. But Efimov's most brilliant solution was the gun installation scheme, which had no analogs in world military affairs. The 2 B-8 mortar could be in 2 positions. In the stowed mode, the mortar's base plate was placed on the roof of the hull, and the barrel was laid horizontally. In this form, the machine could move on roads and rough terrain at full speed, but as soon as the crew received the command to open fire, a real performance began. With the help of a powerful hydraulic system, the mortar folded back. The base plate lowered to the ground and rested on the earth, and the barrel rose to the sky at the required elevation angle. The entire procedure of transitioning from the stowed position to the combat position took mere minutes, and this gave the Tyulpan a colossal advantage over towed mortars, which required much more time for deployment. Loading the mortar was also thought out to the smallest detail. The barrel was lowered to a horizontal position using the same hydraulic system, after which a mine was fed onto the guides from the mechanized ammunition stowage. Then, an automatic ramming of the shot into the barrel bore occurred. The barrel rose to the specified elevation angle, and the weapon was ready for firing. Hydraulics were used for rough aiming in the vertical plane, and a manual drive was used for precise horizontal aiming. Aiming the mortar was carried out using the MP-46 panoramic sight, and the driver's seat was equipped with 2 prism devices and a night vision device for driving in pitch darkness. The commander's turret had a special combined sight with a searchlight for observation and fire correction, as well as for firing from the machine gun installed on it. In 1971, the Tyulpan was officially adopted by the Soviet Army, and this became a real event in the world of artillery. No country on the planet had anything like it. A self-propelled armored mortar of 240mm caliber, capable of arriving at a position on its own, deploying in minutes, and raining mines of monstrous destructive power down on the enemy. A total of about 500 copies of these machines were produced, and each of them represented a concentration of engineering thought, capable of single-handedly changing the course of a local battle. The world did not yet know what the Tyulpan was capable of in real combat, but the wait was not long. The Tyulpan's arsenal is a separate story that takes the breath away of any military specialist. The 2S4 self-propelled mortar uses 6 types of shots, and each of them is designed to solve its specific combat task. Let's start with the most common one. The high-explosive mine 53F864, weighing 137 kilograms. This mine is completed with 5 different charges, which provide an initial velocity from 158 to 362 meters per second and a firing range from 800 meters to almost 10 kilometers. The fuse of this mine allows choosing between instantaneous and delayed action. Instantaneous is used to destroy manpower and light shelters, and delayed is used to destroy concrete fortifications and buried structures, when the mine must first penetrate the ground or wall and only then detonate inside. But if the standard range is not enough, the 3V2 rocket-assisted mine comes into play. This munition already weighs 228 kilograms and is equipped with its own rocket engine, which turns on in flight and pushes the mine to a significantly greater distance. Imagine, a 228-kilogram slug with rocket acceleration flies along a high-angle trajectory and crashes down on enemy positions from a height of several kilometers. The crater after such a hit resembles a small foundation pit, and everything living within a radius of dozens of meters ceases to exist. To strike large areas occupied by enemy infantry, the Tyulpan can fire cluster mines. Such a munition opens in the air as it approaches the target and showers the territory with many small sub-munitions, each of which carries lethal fragments. The coverage of one 240mm cluster mine turns a football field into a continuous kill zone where there are practically no chances to survive. And if the task is to burn out a fortified area or deprive the enemy of cover, SETA incendiary mines are used, which upon falling ignite an area up to 7,850 square meters. Everything that can burn in this zone turns to ashes in minutes. However, regular Tyulpan mines have one significant drawback: accuracy. The mortar fires along a high-angle trajectory, and at a distance of several kilometers, the deviation from the target can be dozens of meters. To solve this problem, the Smelchak guided munition was created, a corrected mine with laser guidance. The principle of operation is as follows. A reconnaissance spotter illuminates the target with a laser beam, and the mine in flight catches the reflected signal and corrects its trajectory, homing in exactly on the illuminated point. If a regular Tyulpan hits a square and can miss by dozens of meters, then the Smelchak hits exactly where needed. The difference between area firing and a precision strike with a guided mine is the difference between carpet bombing and a surgical operation. And finally, the most terrifying thing in the Tyulpan's arsenal is nuclear and neutron munitions. Yes, this mortar is capable of firing special mines with a nuclear warhead with a yield of 2 kilotons in TNT equivalent. One such shot is capable of destroying an entire military town or a tank column on the march. There are also rumors about the existence of mines with a neutron warhead under the names Smola and Fota, whose characteristics are strictly classified. A neutron munition differs from a regular nuclear one in that the main damaging factor is a powerful stream of neutron radiation that kills all living things but leaves equipment and buildings relatively intact. To what extent these rumors correspond to reality, no one outside the narrow circle of people with the appropriate clearance knows. The first test of the Tyulpan in real combat was the war in Afghanistan. 4.2S4 self-propelled mortars became part of the 6th Mortar Battery of the 1074th Artillery Regiment of the 108th Nevelskaya Motorized Rifle Division of the limited contingent of Soviet troops. These machines successfully participated in all major operations and showed lethal effectiveness in mountainous conditions. The high-angle trajectory of the mortar mine turned out to be ideal for hitting targets hiding behind mountain ranges and in deep gorges, where regular howitzers with their flat trajectory firing could not reach. Soviet mortarmen used both standard high-explosive mines and Smelchak-guided ones, which allowed hitting individual mujahideen firing points with surgical precision. The Dutchmen quickly learned to fear the characteristic dull pop of the Tyulpan's shot because they knew that after this sound, they had less than a minute before 130 kilograms of red-hot metal and explosives would crash down from the sky. But even before Afghanistan, the Tyulpan and its predecessor M240 managed to make some noise in the Middle East, where one of the most dramatic wars of the 20th century unfolded. The Soviet Union supplied M240 mortars, and according to some data, also self-propelled 2S4 units to the Egyptian and Syrian armies. And these supplies played a key role in the events of October 1973. The Yom Kippur War began suddenly. On October 6th, on the day of the holy Jewish holiday of Yom Kippur, Egyptian and Syrian troops simultaneously struck Israeli positions from two directions. The Egyptians attacked across the Suez Canal, and the Syrians crashed down on the Golan Heights. And in both cases, 240mm mortars became one of the main tools for breaking through enemy defenses. Egyptian artillerymen used their mortars to destroy heavy Israeli fortifications of the Bar-Lev line, stretching along the eastern bank of the Suez Canal. This line was considered practically impregnable. Powerful concrete bunkers, multi-meter sand embankments, minefields, and wire fences were supposed to stop any attack. The Israeli command was so confident in the reliability of its fortifications that it kept only small garrisons in this sector. And when 240mm mines began to fall on the positions of the defenders, it became clear that no concrete could withstand such hits. 130-kilogram high-explosive shells broke through the roofs of bunkers, filled in trenches, and turned firing points into piles of twisted iron and concrete crumbs. Egyptian sappers, meanwhile, washed away the sand embankments with powerful water cannons, and soon the first pontoon bridges were thrown across the canal. The Bar-Lev line, on the construction of which Israel had spent years and huge funds, fell in mere hours. On the northern front, the Syrians acted no less resolutely. Their mortars were combined into special artillery formations and concentrated on key strike directions. The main target of the Syrian artillerymen became Israeli outposts on Mount Hermon and positions in the Tel Fares area on the Golan Heights. These outposts were packed with communication equipment, radar stations, and observation posts, through which the Israelis coordinated the defense of the entire northern sector of the front. Syrian 240mm mortars rained a barrage of heavy mines down on them, and the result exceeded all expectations. Extremely powerful explosions cut communication lines, destroyed antennas and radars, blinded observation posts, and deprived the Israeli command of the ability to receive intelligence data from forward positions. Syrian assault groups burst into the destroyed outposts without meeting organized resistance. It was then that the words were spoken that entered military history. Alan Hertzberg, an Israeli veteran of the battles on the Golan Heights, later described the consequences of the 240mm mine shelling with chilling frankness. He said that when using these munitions, any warnings of an approaching shelling became meaningless. Not because there was no time to hide, but because there was simply nowhere to hide. If a mine fell near you, you either died instantly, and that was considered lucky, or you remained mutilated by fragments and flying debris to such an extent that it would have been better if you had died. Huge pieces of cast iron, each the size of a man's fist, flew dozens of meters from the explosion site and tore off limbs, pierced bulletproof vests, and turned equipment into a sieve. The craters from hits were of such depth that a passenger car could fit in them, and the shockwave concussed people even hundreds of meters from the epicenter. This war showed the whole world that the 240mm mortar is not just an artillery gun, but a weapon capable of turning the course of an entire battle. It is especially effective in mountainous terrain and urban areas, where the high-angle trajectory allows hitting targets behind buildings and mountain folds that are inaccessible to flat trajectory fire. The Tyulpan can drive up to a distance of only 10 to 20 meters from a multi-story house, raise its barrel to the maximum elevation angle, and fire small charges, reaching an enemy entrenched literally behind the next wall. No other artillery system in the world is capable of working in such conditions with similar destructive power.